Let's take a look at solving an absolute value inequality. What happens if we were to look at the absolute value of a number as less than 3? Let's think what that means in the first place. It means the distance that that value of x is from 0 has to be less than 3 units away. So my answer has to be less than 3 units away from 0. Well, on a number line, just recognize that the number 3 is exactly 3 units away from 0. So that should indicate that the only values that are going to be less than 3 units away is anything in the region between 0 and 3. So I could see that it's everything less than 3 until we get to 0. So in this case right here, we should also recognize that there's another number that's 3 units away from 0. So we could also say that any number that's on the left side of 0 before -3, or after -3 rather, is also going to be an answer. So just try to think of any number that's between -3 and 3, and you'll recognize that plugging it in here will give me a value of the absolute value that's smaller than 3. So that means that in order to solve the absolute value of some expression is less than a number, then all we need to do is find out when is that x value less than that number, or when is it greater than the opposite of that number. Okay, so notice that in this case, once I can combine all of those values in the shaded region here, I see that this is every value from -3 to 3, so as an inequality, I can say that it's -3 is less than x, which is less than 3. But we typically write it in interval notation, and so we're going to want to write that in interval notation in 1 minute. Notice that in general, if we have the absolute value of an expression is less than k, notice how that looks just like this. The absolute value of x is less than 3. Then we just again have to solve two separate inequalities. The first one you solve by just dropping the bars. You need to make sure that that expression is in fact less than k. The second one you solve, you have to flip two things. You have to change the sign of the constant to negative and make sure that that expression is larger than the negative of k. That's going to get me all the values on the left side of 0. So notice in interval notation, the way that we would write this is actually -3 to 3 in parentheses, because there is no equal sign attached to the inequality, and therefore that's our answer. What if we had a greater than symbol though? Notice that now we are again asking what values of x can I plug into this absolute value so that when I get an answer, the values will be greater than 3. Or in other words, more than 3 units away from 0. Well, again, on the right side, notice that 3 is 3 units away from 0. Values that are more than 3 units from 0 will be any values on the right side of 3, like 4 or 5 or 7 or 80. But notice 3 is not the only value that is 3 units away from 0. -3 is also 3 units away from 0. So if I wanted to know what values of x are more than 3 units away, I need to start at 0, move 3 units away, and then realize that the values that are more than 3 units away are on the left side of -3. So notice that we can actually solve this in a very similar way. We can realize that I have answers on the left side and answers on the right side. And so that's why my answer is going to be an or statement, because these two intervals are disconnected from each other. So the values of x that are greater than 3 units away from 0 are going to be anything that's larger than 3 or smaller than -3. So in general, what if we had an absolute value of some expression is greater than a constant? Well, you should realize that here, if we started with this absolute value of x is greater than 3, one of the inequalities we solved was just dropping the absolute value bars. The other inequality told us to flip the inequality sign so that we're actually less than, and now we have to also flip the value of 3. So therefore, to solve any particular inequality with a greater than symbol, we're again dropping the bars. And then the second expression, we're going to flip the inequality to less than and make that constant negative. So if we were to write this in interval notation, looking at this number line from left to right, I could see that it's shaded everywhere from negative infinity on the left side to negative 3, but not including negative 3, which is why there's a parentheses. And then on the right side, it's going to be everything from 3 off to infinity, which is why we again put a parentheses on 3. Let's take a look at a more complicated example here. In order to solve this in order to solve this inequality or absolute value inequality, we again need to get the absolute value bars alone. So let's start off by subtracting 4. That gives me 15 on the right side. Now we're going to divide by 3, which is going to get the absolute value bars alone. Now again, think about what this means. This is telling us that the distance that this quantity is from 0 is more than 5 units away. So on a number line, we would think of this as being everything more than 5 units on the right or more than 5 units away from 0 on the left. So in order to solve, we simply need to create two separate equations. The first one is, when is that whole quantity greater than or equal to 5? But then we also have to figure out when is that quantity less than or equal to the opposite of 5. So this will be the values that we get on the left side of the number line. So if I now add 1, I get negative 2x is greater than or equal to 6. But then over here I get negative 2x is less than or equal to negative 4. And now we have to divide by negative 2. Now this is where you need to remember that whenever you divide an inequality by a negative number, you have to flip the inequality sign. So I know that over on this side, this is going to turn into a less than or equal sign, while this will turn into a greater than or equal symbol. And now we have our answer. I know that everything has to be, all of our answers have to be either less than negative 3 or greater than or equal to 2. Now we could see this on a number line, and that makes sense that if we're here at 0, don't think that these are always going to be equally distant from 0. That's because this was not just x on the inside, it was some other expression where we had to move quantities around. But in order to solve a greater than or equal to inequality, we just need to realize that it's on the outside of the value on the right, and it's on the outside of the value on the left. So in interval notation, we're left with negative infinity to negative 3 with a bracket because negative 3 is allowed. Union, because there's a gap in between the intervals, and now we simply say from the bracket at 2, since 2 is included, all the way to infinity.